So what happened? One neutron hit it, and it broke apart and threw off 3 neutrons. What they didn't show you was energy is given off. A lot of heat actually is given off. Now, just like a very bad rumor mill, okay? If by chance you get a piece of juicy information and you text it to just 3 of your friends, okay? Don't tell anybody, all right? What happens? Those 3 friends tell other 3 friends, and those 3 friends tell other 3 friends, and it becomes really bad. Okay, so by the time you get out of class, it's all over. To continue the process, if we put just a few of them together, we can get a chain reaction, and if you put too much together, you get an uncontrolled chain reaction. And what, again, they're not talking about is the energy. If a ever increasing amount of energy is built and built and built, it becomes something we can't contain and it explodes. But if we just allow a little bit to keep going and we collect a little bit of that energy, we can use that, okay? So you're going to hear the nerdiest guy on this video, okay? And some is going to be a little technical, but I'll go over what we need to know about it. We're going to talk about how we use a nuclear reactor to produce energy. All right, that was good. In terms of the actual area here, oops, didn't want to do that. The actual area here has fuel, the radioactive stuff. It has water surrounding it to kind of slow things down and to absorb the energy that's coming off. And control rods that get between. If I want to shut things down, I put a control rod between and suck up all the neutrons to stop it from breaking other ones, okay? It's a very tight balance, but what happens is, as we get more and more fission occurring, more and more heat is generated. Heats up this water. Now this water is inside a container, and it's inside a container of a bunch of tubes, okay? And it goes into what's called a steam generator. There is a bunch of tubes that come back and come this way, and all the radioactive material is in a sealed container. It's surrounded by water that's not radioactive, but gets hot, and it turns into steam. What happens is there's a fan right here that the steam goes by, just like one of those, you know, little things that you blow and spin. The steam is just pushing a little fan. Inside here is wired coils and a magnet, and if I spin wire coils in a magnet, I create electricity. That's where electricity is formed. The steam gets cooled down to liquid, pumped back up, heated back up into steam, and that cycle just keeps that little spinning fan creating electricity. The nuclear fuel is just to heat water. There are other power plants that burn oil to heat water or burn coal to heat water. But all we're doing is creating steam to run the little fan. An alternative is to dam up a river and allow water to fall to spin the little fan. That's a way to create electricity. Or we put a big fan in the atmosphere and let the wind spin it and create electricity. Now, the wind, not as consistent as we would like, okay? Also, they never ever show you, those big wind farms, they never show you what's at the bottom. Because if the places that have lots of wind are where birds use the wind to migrate right into the fans. So that's not necessarily good for our environment, okay? When we dam up a river, we destroy the habitat both below the dam and above the dam. And so it has some consequences. If we use nuclear fuel, we have waste that we have to take care of. If we burn coal or gas, well, one, we're going to run out of that, and two, we produce gases that might be affecting what's going on in our climate. And so, okay, let's do solar, right? That's just the sun, right? And I have a panel, I collect electricity perfectly well. as you make the stuff inside, there's a lot of waste, heavy metal waste, that are having to be taken care of, and you produce waste. Every electricity that you use, every type of generation, has a consequence to it. Okay? Which consequence are we going to balance? What we can't say is like, okay, so I drive a Prius. I'm not burning fuel. But what if the power plant that you're using is burning oil to create the fuel, the electricity that you're plugging in? I'm not burning it anymore, but I'm making them burn it. Cost shift. Who's doing it? All right? And so there is a consequence to using electricity, and there is some sort of balance that we have to get to, but you have to understand that whatever we use is going to have a consequence. All right? And so when you look at the creation. Now, would you like to live near a nuclear power plant? Okay. Have you ever driven to Hamlin Place? Okay. If you're not driving but in the passenger seat, as you go over the ridge cut, you look back. Watts Dam nuclear power plant is right there. We are right close to a power plant. Now, we have a lot of dams and a lot of nuclear power plants. We're in the TVA. We have some of the cheapest electricity in the country. So we benefit from that, but we also have that right next to us. And you may not even realize how close you may be. Okay. Oh, no, that's the nerd. Okay, fusion. Fusion is what powers the sun. This is something that we're trying to do, and we haven't quite got it yet. But this is a way to create energy without a lot of waste. And the waste that we would create is kind of fun. What you need to know, you don't need to know that chain, but this is what you need to know. The sun uses hydrogen, number 1 element, and it pushes it together to get number 2 element, helium, and a bunch of energy. Okay? Helium is non-toxic, okay, doesn't affect our atmosphere, and is kind of fun if you suck it in. Okay? And if we could ever do this type of reaction, this fusion, we could get a lot of energy and not have a lot of waste. We haven't got there yet. Because in the sun they're so hot and the temperatures and the pressures are so high, we haven't really well been able to produce that here on Earth. Also, what do you hold that in? A beaker? Okay, a little piece of the sun in a beaker? That's kind of hard to do, okay? And so what we have done is this. We don't start with hydrogen. We start with an isotope of hydrogens, one that's a little bit heavier. There's weighs 2 instead of 1 called deuterium, weighs 3 instead of 1 called tritium. So we use kind of heavier ones, and what we do is we shoot lasers at it. And we use the lasers from all different sides to try to fuse it together, okay? And we create energy. Well, that is great, and we can do it. But we can produce about $1 worth of energy if we spend $100 worth of energy. Would you like to buy $1 with your $100? No, it's not economically feasible. So all we do is right this moment is research, but people are looking at trying to do this. Okay, when we have a facility that actually works at this. Now, I don't teach everything by movies, but this movie is actually pretty good. Okay, in terms of showing this. Okay, it's going to use tritium as the source, which is actually something that we do use, and it's going to try to create a fusion reaction.